Disasters are inevitable. Somewhere there's going to be a disaster, and intrinsically we're going to be moved to help out. How do we help out? Send money, send goods, provide our skills, our expertise. Volunteers are a crucial part of the disaster response process. But their unannounced, spontaneous arrival on a disaster scene, if it goes unmanaged, can also create a difficult situation. How else can we contribute without being present even at the disaster scene? Well, it turns out the information age has already changed the way we respond to disasters. When we think back to the 2010 Haiti earthquake, there was no good map available of the affected area. People, volunteers from the OpenStreetMap community, started tracing roads from available satellite imagery and quickly put together a high-resolution map that was being used by responding organizations in that event. And that was just the beginning. With every new major disaster, there's been a new form of technology, a new milestone, and leveraging of crowdsourcing and social media to help respond with disasters. This is a picture of the Kathmandu Living Labs setting up their first situation room in a car park with buildings still rattling behind them from aftershocks. Kathmandu Living Labs mobilized a platform called QuakeMap, and they massively crowdsource what's needed, where it's needed, and who can provide this information. The Nepali army and many other organizations were using crowdsourced information in their own response and organization. So as crowdsourcing and social media have proven to be a successful paradigm in disaster response, the question is, how can we use all this information? How can we make sense of this plethora of data and information and use it for decision making? The other way of phrasing that is there a role for experts to put to test the scientific model, to bring their research, to try to analyze this information as it's becoming available from an event? And can they do it quickly enough to actually support decision makers? The challenge in all of this is delivering the right information to the right person at the right time. The old scientific model is constantly challenged by this fast-pacing environment when we publish our findings months or years after an event has already passed. But there is a new frontier for science, enabled by open access and availability of high-resolution data, and enabled by new forms of collaboration. We started an experiment at the Center of Disaster Management Risk Reduction Technology, CEDM, in 2011. We started an experiment thinking, can we put scientific method and our own know-how and research tool to rapidly start analyzing data as it was becoming available in order to make sense of information, and then quickly generate reports days after the event where we produce our findings. Anytime there is a major disaster, there's 30 or so scientists at the CEDM Center, and a subset of these come together as a task force. We then work intensively, gathering data, making sense of it, and produce our reports days after the event with subsequent updates. We've now analyzed a number of events since 2011, but to give you a better feeling for how a forensic disaster analysis approach works in near real time, let me take you through one example of the work we did after the 2015 Nepal earthquake. There was a tremendous amount of information that was becoming available after the Nepal earthquake. Maps of damaged and destroyed buildings, maps of spontaneous shelter sites were all being put together, crowdsourced, and made available, shared globally on OpenStreetMap. This just shows, the bars show the number of spontaneous shelter sites that were popping up as soon as the satellite imagery became available for these to be mapped. Started with 2,000 spontaneous shelter sites of 5 to 50 tents, and after the second earthquake, there was a fear of aftershocks driving people towards leaving their homes and staying in tents, and by the end of the first month, there were 16,000 spontaneous shelter sites. I'll tell you why this is interesting for us. We were in Nepal 1 year before the earthquake. And we had this research project with a shelter demand model where we tried to look at what would be the capacity of Kathmandu city to house and accommodate displaced persons. And we ran a scenario earthquake to see where would people be displaced and how many people would be displaced. And when we looked at this data, our model utterly failed. The reason is that we were looking at designated open spaces. Spaces the government created and said these are going to be managed sites that people are going to come to after a major earthquake. And it turns out people did not like going to those open spaces. They preferred much more to stay close to their homes, in their neighborhoods, social ties and livelihoods, and set up these spontaneous shelter sites scattered all around the city and other parts of Kathmandu in small spaces that were available anywhere near their damaged buildings. So we wanted to understand that. That had implications on our model. We went to the field, 4 of us, 6 weeks after the earthquake, developed this shelter survey to look at decision factors among households and how they seek shelter. And as we were talking to organizations, we came across the International Organization for Migration, IOM, and they had very similar questions. The monsoon was coming up. They knew already people reacted to the aftershocks, and they expected there would be another wave of spontaneous sheltering in the monsoon with the fear of landslides. And they were very interested to see a group of researchers are following this. We sat down with them and actually integrated some of their questions into our survey. And in this way, when we did our analysis, we were able to feed back into that mechanism and help them with some of their operations on the ground. Now, we happened to meet IOM and happened to be in Nepal and understand that our research has value to actual decision makers on the ground. But what's missing? We are able to produce all kinds of reports. Right after the earthquake, 2 days, we produce our initial report of our findings of the earthquake. And before the second earthquake on 12th of May, we produced 2 more reports. We went into the field in June, came back with our shelter survey, and looked at that and presented that and gave it to the organizations that we were involved with in the field. And then we transitioned from a task force more into a research team and followed up in more in-depth investigation in a second survey, and a third one just in April, where we also attended a conference and presented our findings. How do we bring a more effective dialogue between researchers like us and people who might actually benefit from our research? Disasters focus our attention. They provide an opportunity for people to be looking at the same picture, and media helps out with that. People want to help. How can we leverage that? How can we create a more effective dialogue where people who have issues and problems after a disaster can express those, and those that have the expertise to solve them can provide their knowledge and make that available? For the remainder of the talk, I want to provide you with 3 possibilities, 3 ways, 3 existing platforms that are there for scientists and experts to already contribute to this process. Documentation is a big part of what we do as scientists. It turns out the most powerful implementation of documenting disasters to date is Wikipedia. With its integration of the powers of the World Wide Web and the collective intelligence of its millions of contributors, it's coming and approaching close to the ideal of a global memory. 148,000 disaster-related articles are in Wikipedia. And if you type any disaster name in Google, the first search result will be a Wikipedia page. Incidentally, 70% of the edits on disasters made after 2008, that's a year when Wikipedia got a little bit more popularity in terms of this, are made within the first 2 weeks. In other words, the place people go to find out information about disaster has content that's generated in only 2 weeks. I started looking at this and Wikipedia entries on disasters after 2001 for big earthquakes with more than 100 fatalities. And it's striking to see the Indian Ocean tsunami in 2004 and Katrina hurricane in 2005, events that are 10 years back, are still getting upwards of 100,000 views. That's a huge impact in terms of reaching the public. What's also striking to see are still large earthquakes, the 2005 Kashmir earthquake, 2001 Gujarat earthquake. We have a wealth of information about this in the science literature, but just a few kilobytes of text on them on Wikipedia pages. There is certainly room to improve content on these entries in Wikipedia. And Wikipedia can not be just the #1 place people go to learn about information on disasters, but it can also be the most reliable, near real-time source of disaster information. If documentation is one pillar of science communication, deliberation surely must be another. Deliberation is the thoughtful process of weighing options, using both facts and value. Deliberation gets complex. On blogs, on Facebook-style conversation, it's hard sometimes to see the good stuff for all the noise. There's an innovative tool the MIT Center for Collective Intelligence put out in the world called the Deliberatorium. The trick with Deliberatorium is that it organizes contributions by topic rather than by the order which they appear. Anyone on the Deliberatorium can present an issue, and others can come up with ideas or options to address those issues. While others look at those ideas, they might offer arguments and information supporting that, or arguments and information rebutting it. The trick here is that you have to unbundle your thoughts into points that present one issue, one idea, one argument. And it quickly allows you to see an argument map and find where your points can be located, and perhaps see if they've been made already, and allows for collective intelligence to be sampled and among a diverse, distributed, and large group of stakeholders to arrive at some solution ideas. We collaborated with Mark Klein, the developer of the Deliberatorium platform, in a Rockefeller Challenge grant to look at the application of this platform in disasters. A disaster collaboratorium where all kinds of stakeholders can get together and express issues that are becoming relevant in real time and seek the global intelligence, the global wisdom, the knowledge and information of a various group of experts that can contribute to that would be a very powerful tool. Finally, just because you have a solution idea doesn't mean you've solved a problem. Solving problems require resources, require effort, and that usually means funding. Luckily, there's over 500 different crowdfunding platforms available where people can present their ideas and then seek to get funding from the crowd if their ideas are interesting enough. And one of these put two very big problems and disasters together and came up with an innovative solution. One is the issue of debris and garbage and concrete has big environmental impact after the damage and destruction of a disaster. How do you deal with that? And the other is, how do you provide housing to people in a disaster when the price of construction material is high and it's rare to find construction material? And a concrete engineer and expert thought about creating a geopolymer concrete out of this recycled material to address the sheltering issue at low cost and high values of production. And he got funded by the crowd to test his idea, and he's looking for a second phase. So I've talked to you about how we at SADM use our skills, our methods, our analysis to generate findings, interpret, and insight after a disaster, and do it in real time, near real time. I think this can be scaled up to include many more. There's just 30 of us at SADM. But imagine the power of the world's experts coming together and working for a limited time in this type of mode. I also presented a few platforms any expert can now go to and a way of contributing their knowledge. What if we could cultivate a global brain with its roots deep and wide, so that people who needed information could tap into that, express their problems, and seek solutions. So if you're an expert, or you're a scientist, a practitioner, anyone with any knowledge or skill that can contribute to a disaster, I want to put out a challenge, a call to action. If you believe in the power of collective intelligence to solve problems with a diverse, distributed, large crowd, a next event will focus the world's attention. It's an opportunity for us to get involved. It's an opportunity to see what would be the issues that are arising, and maybe you're the one who will have the right solution to the right person at the right time. Thank you.